I hope the concepts are clear. So congruency basically says that if A is congruent to B mod n, that is nothing but, that is simply saying that n divides A minus B. This is the basic concept. The applications of modular arithmetic. So especially when we talked about divisibility of numbers, there is a lot of interesting things with sum of digits. There is a divisibility identity. Hello everyone, welcome to this new video. Welcome to the second week of this course. And yeah, I think yesterday was our live session, so this is being recorded beforehand. So I'm going to speak in terms of future. Crazy, like time traveling. This video is going to travel to time Tuesday. Right. Anyways, so I hope you're all doing very well. I know that the previous recorded video on the congruency of integers was a bit rushed. Personally, I admit that I was not doing that well. I was a bit ill that day, but today I'm totally fresh, right? I'm totally good, and I will try to clarify on the concepts. I hope the concepts are clear on the congruency of integers. That should be clear, because it's basically, what does congruency basically say? So congruency basically says that if A is congruent to B mod n, that is nothing but, that is simply saying that n divides A minus B. This is the basic concept. That's it. So in other words, A and B give same remainder when divided by n. So that is the basic thing. That is the definition. From this only we build so many things. We talked about a modular arithmetic, right? So arithmetic means we do, so this satisfies plus minus okay, plus minus product also it satisfies, but division is a bit complicated. This is a bit complicated, but all these three are satisfied, right? If A is congruent to B mod n, and C is congruent to D mod n, then you know that A plus or minus C is congruent to B plus or minus D, and mod n, and AC is also congruent to BD, right? I could have taken some other space, but I hope you, okay, right? Now today we are going to expand a little bit on that. We also said that a constant could be multiplied, which is not in the modulo n part. Constant can be multiplied from outside, and even that satisfies everything, right? So if A is congruent to B mod n, then AK will be congruent to BK. But this implication is okay, but can we go from here to here? This is possible only if, do you remember, it is possible only if k comma n is 1. GCD of k and n is 1. This has to be okay. I hope so far I have covered almost everything which we need to know about today from the previous session. Okay, let's move ahead. Now in today's session, especially, we are going to deal a lot about the applications of modular arithmetic. So especially when we talked about divisibility of numbers, I skipped the part of 11. Now we are going to bring it back, right? So let's see how we do that. So let's look at, what is the divisibility rule of 11? What is it? we add the, it is the difference between the sum of alternative numbers, sums of alternative position numbers and digits, right? That's the definition. I hope that is visible, right? So how do we prove that? Okay, let's look at 10, right? Okay, before that, there is another thing which I should mention. I think it is also important that if A is congruent to B mod n. Oh, by the way, this is one of the notations. Every time I need not write mod n, I can simply write bracket n, right? Then A power some m will be congruent to B power m, all the same, right? I hope that's also clear. Now, 10 color 10 is congruent to -1 mod 11, isn't it? Isn't that right? That is correct. So 10 power n for any n will be congruent to -1 whole power n mod 11. Now, if you are wondering why is this, let me just write 10 is equal to -1 plus 11, right? The basic difference. Or you can also write 11 divides 10 minus, right? That is also possible. So this is true. This is true all the times. Now we use this to prove our divisibility rule of 11. Now any number, let's say n is, I don't know, k digit number. So I'll write n as, if it is k digit number, it can be written as ak minus 1 dot till a2 and a1, like this. Like this is these are the digits, right? But writing it actually base 10, again we'll also talk about number bases. That's a very interesting concept. Yeah, that's also a very interesting concept, number bases, but presently we are of course dealing with base 10. So this will be, if there are 10 digits, then kth digit will have ak into 10 power k minus plus ak minus 1 into 10 power plus dot till a2 into 10 plus a1 power 0, a1 into 10 power 0, right? Okay, now we look at this. So we will take n mod will be congruent to, now each of these, if I am taking mod 11, right, now we take mod 11, this will be equivalent to ak into, what is that, minus 1 power k minus plus ak minus 1 into 10 power k minus 2. 10 power k minus 2 will be converted to minus 1 power k minus 2, right? Dot till a2 into minus 1 power 1 plus a1 into minus 1 power 0, right. So this will be congruent to, let's start from a1, right. So it is a1 minus a2 plus a3 minus a4 plus dot 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 till plus minus 1 power k minus 1 ak mod 11. Is that understood? Now for a number to be, now I can also rewrite this, let me do that in the next slide. So basically I have n is congruent to, if you look at it carefully, you see that a1, a3, a5, all the odd positions will have positive value, a2, a4 and all the even position will have negative value. So I will in general write this is equivalent to a1 plus a3 plus a5 plus dot dot dot. I won't write the final term because we know that it is a finite number of terms, so I am not specifying that, minus a2 plus a4 plus a6 plus dot dot dot. Now all this is happening under mod 11, right. Now if now it becomes simple, if 11 divides n, that should imply n should be congruent to 0 mod 11, right. That's an obvious statement. So we need to have n needs to be congruent to 0 mod 7, so that implies mod 11 implies a1 plus a3 plus a5 plus dot 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 minus a2 plus a4 plus 6 needs to be, it need not be 0, it needs to be 0 mod 11, which implies 11 must divide a1 plus a3 plus a5, the odd position, the sum of the digits at the odd places minus the sum of the digits at the even place. Okay, I hope this is clear. So from here, we get the divisibility rule for, I hope that is clear. I'll give you some time to, okay, you can just pause the video and get this written in your notes you are taking. Now there is a lot of interesting things with the sum of digits. If Sn is the, okay, this should be sum of digits. Supposed to be sum of digits. Okay, this is practically the divisibility rule of 9 as well, 9, 3, everything, right. This is actually divisibility rule of 9. So this should be clear, this shouldn't be a big problem. But if you see, what are the uses of this? It's a very interesting thing if you notice that there is a cyclicity when you take powers of numbers. Although we will do a separate lecture based on unit digits and last 2 digits, all those things, covering all that. But now I want to briefly tell you, if you take 2 power n mod 9, In fact, if you take any number power n mod anything, there is a very interesting pattern which you will observe. Okay. So, I leave this to you as a homework, because the next question is going to be related to this. Now, why is this true? Why is this, if n is, so Sn basically, if n is equal to again ak minus 1 a2 a1, then Sn is simply ak plus ak minus 1 plus 2 plus, right. Now, that's obvious, and then now this can be written as 10 power k minus 1 into ak till a2 into 10 power 1 plus a1. So, if I subtract n minus Sn, that will simply be, if you look at that, n minus Sn, 10 power k minus 1 minus 1 ak plus go on till 10 minus 1 a2 plus 0 into a1. Now, we need to look at 10 is congruent to 1 mod n, 1 mod 9, sorry, right. 10 is simply 1 plus 9. That should imply that 10 power n is congruent to 1 power n, which is 1 itself, mod 9. So, that will imply that 10 power n in the sense anything, any number k, because n is already used, k minus 1 is congruent to 0 mod 9, which implies all of these terms here we will have 10 power k minus 2 minus 1 ak minus 1, right. So, all of these terms are 0 mod. So, that tells you that n congruent to Sn, or rather Sn is congruent to n mod 9. There is no difference. Is that clear? Now, we will do a question which is related to this. So, if this is clear, let us move on, and if something is not clear, you know where to get in touch with me, right. You know where to get in touch with me. This is where you get in touch with me, in Telegram, right. What is it? There's a right. I guess that's the symbol of Telegram. So, many people were asking me that I am presently in my 11th, 12th. How do I should I even prepare for IOQM? How do I manage my time, my JEE or other preparation, right. There is a lot of family pressure. Even though I am not interested in JEE, I have to do because my parents want. See, buddy, I have been through that, right. I have been through that. Trust me, even now my parents try to kind of get some control over me, that why are you doing here, why teaching, is teaching really appreciated in the society? I don't think so. Not a lot of people really admire teaching, although it's a good profession and all that. It's a noble profession, every teacher must be respected, everything is there, but it is not really appreciated as much. So, don't you think I am facing that? I am facing that, everyone is facing that, and everyone has to go through that, and everyone has to fight back a little bit. And I understand that at your age it is tough, and when I was that age, I didn't even know that I had to fight back. So, I can only answer with my own personal experience, right. I can only say that you have to figure it out. you have to figure it out. There is no written roadmap how to manage time and everything. You have to make a schedule for yourself. You have to pull out some time to do something which you love, right? At your age, I understand that you cannot get out of your house. You have to be under the control of your parents. Everyone is at that age, but then you have to somehow pull out some time for yourself. Be it, I don't know, I'm not asking you to wake up late at night, but maybe cut down on the things which you are doing unnecessarily, like watching phone, like spending time on movies or something. So if you have any spare time, try to put that into something which you love, right? And I will call you a liar if you are saying that no sir, there is no time left for me, because there will always be some time. 10 minutes, half an hour, right? Half an hour, more than enough. If you want to really prepare for IOQM, watch my videos in 2x speed, I don't mind, right? Half an hour a day, just spend time on what you love. Books I have mentioned, right? Maybe I'll make another separate video, a small short or something on books. But come on man, you have to do something for yourself, right? You cannot expect me to rectify all the problems. And it's not that I'm really glad that you are expecting me to solve your problem. I really want to. I want to be that mentor in you. But I can only take you a little bit far, right? I can only take you few steps. I can just push you when you are cycling, but you have to at the end pedal your way, right? You have to pedal your way. So let's get back to the question. 2 power 29 is a 9-digit number which is said to contain 9 out of the first 10 whole numbers. What are the first 10 whole numbers? 0, 1, 2 till. So 2 power 29 is a 9-digit number which apparently has 9 of these numbers, 9 of these digits, and we have to figure out, I think, which number is missing. Find out the whole number that is missing. Okay. Now again, it is related to sum of the digits. What is the sum of 0 plus 1 plus 2 plus till 9? I hope you know the story of Gauss, right? Where he adds from 1 to 100. We'll talk about that when we are doing arithmetic. So Gauss is like the genius kid. Yeah, come on. Okay. Now this happens to be, I think, 45. This happens to be 45, which is 0. Okay. Now what is the sum of digits of 2 power 29 mod 9? As we did before, it has to be 2 power 29 mod 9, right? So we need to figure out what is 2 power 29 mod 9. Okay. What is the closest power of 2 to 9? Closest power of 2 to 9 is 2 cube. 2 cube is 8, which is congruent to minus 1 mod 9. Yeah, that's true. So can we take some power of 3 is closer to this? Closest is 27. So 2 cube whole power 9 will be congruent to minus 1 whole power 9 mod. This implies 2 power 27 congruent to minus 1 mod 9. And that would imply that 2 power 29 congruent to So, to get 2 power 29 I need to multiply 2 power, okay, this is congruent to 2 power 27 times 2 power 2, let us not write anything, which is congruent to minus 1 into 2 power 2 9. So, that is, so 2 power 29 is congruent to minus 4. So, which number is missing? Tell me in the comments, I am not going to answer this. So, if 2 power 29 is, oh, we have a spare thing. So, 2 power 29 is congruent to minus 4 mod 9, which is also congruent to, by the way, 5 mod 9, which implies the sum of digits of 2 power 29 congruent to 5 mod 9. So, which digit is missing? Which digit is missing? So, what do we need? If the missing digit is added, if missing digit is added, it should be equivalent to 0 mod 9. That's the greatest hint I can give you. So, now you answer which number is missing. So, which digit is missing? Right? Now, there is a divisibility identity, right? This should be very much well known to all of you. This is an algebraic identity actually. So, this algebraic identity can be very easily seen using, modular stuff, congruency of integers, although it is not needed to be integers a and b, but we do find it easy this. So, if so the identity says, so let me write down the heading. A minus b divides power n for all a belong to integers, natural numbers. Let us talk about only positive integers, right? Okay. Although it is true for all real numbers a and b, but the power has to be a natural. So, how do we do this? Okay, let us first see, let a minus b is equal to n. N is already used, so let us say m. That should imply that a is congruent to mod m. So easy. Now you take power n, right? You get a power n is congruent to b power n mod m. That will imply a power n minus b power n to 0. In other words, this implies m divides a power n minus b. And what was m? M was this. So, we simply say a minus b divides a power n minus. Okay, that clear? And here we are just taking integers, but again I am telling you that is true for all the, we say, real numbers, for all the real numbers. need not be integers, but n has to be an integer. Okay, I left where okay. So yeah, that's all the concepts which I was going to cover. The time, it's 30 minutes. Pretty good, not bad. So we are going to solve a few questions and then go for the assignments. Have fun. So the smallest positive integer x such that this is happening. Again, we talked about division, right? How can we divide? When can I divide? If ax is equal to ab mod n. A can be cancelled. It implies x is congruent to b mod n only if a comma n is 1. GCD of a comma n is 1, right? So first of all, can we get a power of multiple of 5 in the right hand side? Can you tell me a number which is 1 mod 12 and is a multiple of 5? I'm pretty sure you could think of this. I really wish we do some live sessions, we do more live sessions. It will be more fun. So we can see that 25 is congruent to 1 mod 12, because 25 minus 1 is 24, right, which is divisible by 12 basically. So that implies, do I have spare? So that implies 5x is congruent to 25 mod 12, and since 5 comma 12, the GCD is 1. Please check. The GCD is 1. There is no other common divisor, right? I'm so sorry. There is no other common divisor. There is only 1. Yeah. So the greatest common divisor between 5 and 12 is 1. So we can cancel out 5 and 5 here. So x has to be congruent to 5 mod. So whenever this is true, this is how actually you solve a lot of congruency related equations, right? Okay, this is one of the very interesting questions. It's actually quite cool. Okay, let's go ahead. So it is very important to remember, again I am repeating, ax is congruent to ab mod n will imply, you can cancel out a only if, I'm not having any fun writing it again and again, but so important, we very often forget this. I don't want you to forget this. Only if a comma n. Okay. Show that if a is congruent to b mod n. Okay, I don't know why I gave this question. I mean, that's so simple. That's so stupidly simple. Yeah. So a is congruent to b implies a cube is congruent to b cube mod n. And if a is congruent to b, then 2a is congruent to 2b. 2a is congruent to 2b. I don't know. You just add them. It is just a cube plus 2a is congruent. You can in fact reverse the orders. This is also equivalent to saying 2b congruent to 2a, right? Mod n. So you can actually say this is mod n. சரியா? அப்புறம் என்ன பண்ணீங்க? நல்லா இருக்கீங்களா நீங்களா? So you can actually write a cube plus 2b is congruent to b cube plus 2a. This is like playing around. This is nothing. Playing around stuff. Okay. Move ahead. I'm glad I didn't give fair sheet for this one. Okay. Oh, this is the playing around stuff we just did. A is congruent to 2 mod 5, B is congruent to 4 mod 5. We need to compute this. That's so cool. Let's see. So A is congruent to 2 mod 5. So what is A square? A square is congruent to 4 mod. And we have B is congruent to 4 mod 5. What is B square congruent to? Which is 4 square, so it has to be 16. But you know, while calculating these kind of questions, we often prefer to have smaller, to reduce the numbers, right? Of course. In fact, I would have written this is minus 1, 4 as minus 1. See, this is also congruent to minus 1 mod 5. That would make it even more easier, but still. So 16 is 15 plus 1. So this is congruent to 1 mod, right? Okay. Now let's just add up all those things. So A square B congruent to A square into B. Again, it's 4 into 4, 16. So it has to be 1 mod 5. Right? It is actually 16. I'm writing 1. And AB square congruent to mod 5. Right? So we simply add them. A square B, AB square congruent to 1 plus 2, 3, 5. We can solve this in another way. How do we solve this? You see that A square B plus AB square can be written as AB into A plus B, right? Now, method 2, way 2. This is way 1. We know A, we know B. What is A plus B? A plus B is congruent to 4 plus 2, 6. 6 mod 7, 6 mod 5, sorry, which is actually 1 mod 5. Okay. What is AB? AB is congruent to 2 into 4, 8 mod 5, which is 3 mod 5. So AB into A plus B be congruent to 3 into 1 mod. So we got the same result. I hope it is clear. Yeah. So compute the remainder when 7 power 2222 plus 5 power 1111 is divided by 9. So essentially we are computing the we are kind of computing the sum of the digits mod 9. So let's have a look at it. First of all, what is 7 mod 9? 7 is congruent to minus 2. Okay. And 5 is congruent to 4 mod 9. These minus signs often help us a lot. Now we will see why. Now, what is 7 power 2 to 2? Congruent to minus 2 power 2 2 2 2 9, which is congruent to 4 power 1 1 1. Would you agree? Now you see where we are getting at. What is 5 power 1 1 1 1 congruent to? It is minus 4 power 1 1 1 1 mod, which is simply minus 4 power 1 1 1. You see the difference? The 4 was inside the base, now it is outside the base. It is outside the exponent actually, mod 9. So simply that should simply imply 7 power 2 2 2 2 plus 5 power 1 1 1 1 is congruent to 0, and that should imply 9 divides this. So the remainder is 0, implies 9 divides 7 power 2 2 2 plus 5 power 1 1. Is that clear? Is that clear? Yep, this is simple stuff. So you see how much it helps. Modular arithmetic, congruency of integers is cool stuff. Okay, that's all I had. Like, share, subscribe and all those things. Whatever you want to talk about, you can talk to me in the comments, private chat, anywhere. Okay, so that's all for this session. Meet you all in the next one. Thank you.